Hey guys, welcome back to another college algebra lesson. We're going to talk today about function notation. Okay, most of you guys know what that is, function notation. You know that from Algebra 2. You may not be terribly familiar with piecewise functions, though you should be. Those are the two ideas that we're going to talk about today, function notation and then piecewise functions. We'll put those two things together. All right, so let's look at some function notation. As you guys know already, if we use this notation right here, f of x, that's just a representation of the y value. All right, so that's representation of the y value. So let's look at an example here. Okay, so here's f of x equals x squared minus 3x plus 5. Okay, and then recall what that means. Okay, recall what that means. It means if I put a 2 in here, well, for everywhere there's an x, I'm going to put a 2 in there. And so this expression, it now becomes 2 squared minus 3 times 2 plus 5. So remember, the x's are they're placeholders. They can take the place of anything. I could put triangle in here. And so then we'd have a triangle here and a triangle here. Oh, that didn't work. So I would have then triangle squared minus 3 times triangle plus 5. Now, this one we can't simplify, obviously. But the green one we can. That's 4 minus 6 plus 5. So that's 3. So we would say that f of 2 equals 3. And please note here then on the graph, the x value is 2, the y value is 3. So that gives us a point that's on the graph. We know that it's 2, 3. Okay, so there's a couple different ways to use function notation there. Okay, but what about this scenario? Okay, so here I have f of x equals x squared minus 3x plus 5, the same idea. But now what if I have f of x plus 2? How does that change things? Okay, how does that change things? Well, the same thing. Everywhere there is an x here, everywhere there is an x here, we are going to replace it with x plus 2. So what we'll do, everywhere we've underlined the x, we're going to put in x plus 2. So here I have an underlined x. So this is equal to, we're going to put an underlined x. Instead, we're going to put x plus 2. So x plus 2 squared minus 3. Well, there's another x. So we're going to put that here. I should have left these in parentheses. So x plus 2. And then plus 5. Okay, so now we can simplify this expression. If you don't know what this is, please pause it, work it out. Since I know what it's equal to, I'm going to write it. So this is x squared plus 4x plus 4. Now this negative gets distributed to both places there. Minus 3x minus 6 plus 5. So this is x squared. We've used that up. Plus x. And then 4 minus 6 plus 5 is plus 3. Okay. So that's what happens when we take this expression right here and we plug in x plus 2. We get a different expression. Right? And this is useful. This one way we'll use this is in calculus as you get there. So it is useful. It may not seem like it right now, but it is useful as we get on down the line. All right. Last thing we're going to talk about is piecewise functions. Piecewise functions. Okay, so this has two pieces here, and this is, I'm going to guess, new to a lot of you. So there are two pieces here, And the key thing here is this tells us where in the domain it is, right here. So part 1 right here is only good when x is less than or equal to 1, and part 2 is good when x is greater than 1. I'm going to guess that you've done a little bit of this, so I'm going to show you what this graph looks like. Desmos has a fancy way of showing this. Okay, so let's move our vertical line here to 1. Okay, so notice at 1 here, our graphs have split. When x is less than 1, I move it to the left. It's the line 2x plus 1. And then when x is greater than 1, I'm on this parabola right here, x squared minus 5. Okay, so that's what the graph looks like. But we're worried about function notation, so we want to know what f of 2 is right here. Well, notice that 2 is the x value. X is greater than 1 here, so we're going to use this piece right here. So this means that we're going to use 2 squared minus 5. I'm going to take this 2 and I'm going to plug it in right there. So that equals negative 1. So f of 2 equals negative 1. Okay, that's a lot going on there. So I'm gonna dilute. Try to. Oh, maybe I won't. Okay. Here's the next one. F of 0. F of 0. Well, notice that this x value is less than or equal to 1. So I'm going to plug in 0 right there. So this equals 2 times 0 plus 1. That equals 1. So f of 0 equals 1. Let's look at that on the graph. This is 0. So this is 0. I'm going to change this x value to 0. Okay, so please notice that right here, I have a point 0, 1. Okay, this one right here, when x equals 2, let's go to x equals 2. Okay, so notice I have a point 2, negative 1 right here. Okay, those are the ones that we've done. Now, where does f of 1 fit? Okay, well, is x greater than 1 in this case? Well, no, that's not the case. But x is less than or equal to 1. That fits that scenario. So we're going to go put 1 up in here. So that's 2 times 1 plus 1. That's equal to 3. So f of 1 equals 3. Okay, we'll look at that on the graph also. I know we're getting a little long-winded here, but let's move this x equal to 1. And notice here that 1, 3 is on the graph. Okay, 1, 3 is on the graph. It's not down here. All right, that's not part of the graph. It's up here at 1, 3. All right. Hey guys, thanks for watching. I know this got a little long-winded.